Counting sort, a sorting algorithm. We will start by creating a new Java project. Let's name it counting sort. Then a new package and a new Java class. Inside the Java class, which we will name counting sort, we will implement the main method. Now we're going to start writing some code, like an array. Let's take some random numbers, like 4, 2, 2, 8, 3, 3 and 1. As you can see, it is not sorted, and our job is to sort this array. Then we will print this list, and we will say this is the unsorted array. And we will create a for loop. Like that. Then we will leave an empty space. After that we need the size. We create a variable, an integer, and we will say this is the data length. And we will create a method, the count sort method, which will take data and size. These are our two parameters. Then we need another system out print line, and we will say this is the sorted part. And we can just call the array to string. We will say data arrays. I'm sorry. So we need to implement this class, to import this class. Now, as you can see, it has its color. Now the compiler complains because we don't have this method, but we can create it like that. And we will say we need an array here. This will be our array, integer array, or you can also write it like that. It's the same thing. And we will say we also need the size of the array. First of all, we will create a new array with the size length of the array +1. To do that, we will say this is the output, and it will be a new integer array, size +1. Then we will find the largest element of the array. First need a variable max, and we will say this is the position 0 of the array, in other words the first element. And then we will create a for loop, a simple for loop. We will say int I less than size, then increment by 1, and if the array I is greater than the max element, then I want you to put inside the max variable the array I. So after that we go outside of this for loop, and we will say int count count, so this is a new array, will be new integer array max plus 1. And then we will initialize the count array with all zeros. We'll say int less than max. And careful here, the increment will happen before we initialize the I. That's why we need the 2 plus before the I. And then we just say count I will be 0. Then we will store the count of each element. Again, another for loop. Less than size I plus plus, and then count array I will increment by 1. Then we will store the cumulative count of each array. To do that, we will say for int is I less or equal than max, and then I plus plus, and inside the loop we will say count I plus equals count I minus 1, like that. And as you can probably see here, I made a small mistake. The plus plus goes here after the parenthesis. Now, after this for loop, now we have stored the cumulative count of each array, and now we will find the index of each element of the original array in the count array and place the elements in the output array. To do that, we need another for loop, and we will say int I equals size minus 1. Then we'll say as long as the I is greater or equal than 0, and we will decrement by 1 in each loop. Then the output count array I, and this is minus 1, we'll take the value of the array I. You can see our theory video if you don't understand something that I write. And then we will say the count, the array I decremented by 1. Finally, we will copy the sorted elements into the original array. In order to do that, we need another for loop. And this is like machine learning, where we need so many for loops that you can't even imagine. And then inside the for loop, we will say that the array I element, we will take the value of the output I element. And that's how we copy the sorted elements in the original array. And again, the decrement here happens that way. Now you can save this code, and we can run it in order to see if the sorted array works. And here we have a line. Maybe it's better if we do it with print and save it again. And now, as you can see, the first line is the unsorted array, and after our algorithm, the array is now sorted 1, 2, 2, 3, 3, 4, and 8.